Okay, so what we're going to do is we're going to talk about the sum or difference of two cubes today. And this is another factoring pattern, and so you need to get this down. If you don't have it down, you need to get this down. Okay, the sum or difference of two cubes. And so anyway, I'll go ahead and let you write that down, and then I'll continue and we'll talk a little bit about that. Okay, so here are some things that you can do to remember what you do. First of all, cubes. You're looking for numbers that when you take them times themselves 3 times, that is what a cube is. So the first few cubes, you're going to have 1, 2, 3, 4, 5. The first cube is 1. The next cube is 8, 27, 64, and 125. And so you might want to file those away. Okay, 6 cubed is actually 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. And so those are numbers that you should kind of be familiar with. And so when you see those, you should start thinking, oh, that's a cube. And so I've got a cubed plus b cubed. And the first thing I'm going to do is I'm going to take the cube root, or I'm going to find out the base. That's the very first thing I'm going to do. And I'm going to actually call this row 1. And then what I'm going to do is whatever is in row 1, I'm going to square it. And I'm going to write that down. And that's going to be row 2. A little bit about the rows. You will always use row 1 twice. You will always use row 2 once. So twice, once. And so this is how you factor. I'm going to start with the little one first with 2 terms. Those 2 terms are taken from row 1. Okay? So how many more times do I have to use row 1? Once, because I've already used it once. Now this is the thing. Whatever sign I have here is whatever sign goes here. So whatever sign you start with here is whatever sign you have here. So I went ahead and used row 1. Now I'm going to move to row 2 for my second bunch. My second bunch is the big one. Okay, so here's row 2. This sign here is always going to be the opposite. This is going to be row 1 multiplied together. My last sign will always be positive.
Okay.
And then the only term I have left is the b squared. So real quick again, if you do your a squared, b squared, I'm going to do a minus b because remember these signs have to match. I'm going to go to row 2 and get my a squared. This sign will always be the opposite of whatever you just got done doing. You have ab and then b squared. So let's look at an example and get right into this. Okay, here we go. Factor each polynomial. If the polynomial cannot be factored, you write the word prime.
Prime.
So I have 16x to the 4th plus 54xy cubed. First thing I'm going to do is examine the 2 coefficients. So I'm going to examine the 16 and the 54. And I'm going to say, is there something in common with those? 2. So I'm going to factor a 2 out. Now what I'm going to do is look to see if there's any other variables in common. X to the 4th and x. So I'm going to take out an x. So let's see what I'm left with. If I take a 2x from 16x to the 4th, I'm left with 8x cubed. If I take a 2x from 54xy to the 3rd, what am I left with? 27y cubed. So now I look and I see the numbers 8 and 27 and I think, oh, those are perfect cubes.
Wow.
Okay? I know that 2 is cubed to give me 8, and I know that x is cubed to give me x to the 3rd. With the 27, what is cubed to give me 27? 3 and y. Here's a trick for your exponents to determine if a variable is cubed. It's got to be a multiple of 3. So example, if I had like x to the 6th, that is cubed. Divide that by 3, and that would be x squared. If you had x to the 9th, what would be cubed to give me x to the 9th? X to the 3rd. So in order for it to be cubed, it has to be a multiple of 3. Okay? Yes?
How did you get 8x cubed instead of like 8x like 5?
Because I took an x out from x to the 4th. So if you take an x away from x to the 4th, you're left with x cubed.
Well, I know, but why didn't you add them? Like, there's a plus sign there.
What do you mean add them?
Never mind.
No, I'm not following what you mean
Never
when you say
mind.
add. Whenever you factor something out, you basically divide it. So I've divided the 16 by 2 to get 8. I've divided the x to the 4th by x, and I get x cubed. So then now, if you remember, that's row 1. I'm going to use row 1 twice. Row 2, I'm going to square each of these. So if I square 2x, what am I left with? 4x squared. If you square 3y, what are you left with? 9y squared. So now I'm ready to go ahead and jump into my factoring. The first term will be 2x. Then I have a little set of parentheses. Then I have a bigger set of parentheses. So inside the little set of parentheses, I'm going to put row 1, which is the 2x and the 3y. What sign will go between them? Plus. The reason why it's plus is because that is the same sign as what I started with. So far I've used row 1 once. Do we remember what we start with here? 4x squared. What sign will I have? Minus. Okay, so I've used the 4x squared. What do I do now?
9y squared. No?
I do 2x times 3y. Remember, I do my row 1 again.
Oh, yeah.
And then what will the sign of my last term be?
Plus.
Plus, and the only
9y.
term I haven't used is 9y squared. Now what I need to do is go ahead and multiply 2x times 3y. And some of you could probably do this without writing it down in the green step. You could probably go directly to your answer. So what is 2x times 3y? 6xy plus 9y squared. And there you go. That is your answer. Okay.
Are we doing all 12 slides?
All right, so we're going to go ahead and look at that bottom one. 9y cubed plus 5x cubed. So is there something in common that you can take out with the 9 and the 5?
No way, Jose.
No, there's nothing in common. So now I need to look. Is 9 a perfect cube?
Yeah.
What is cubed to give me 9?
Wait, no, nothing.
What's 3 times 3 times 3?
27.
27.
Nothing. Prime.
There's nothing that's cubed to give me 9. I can't factor it out. So as a result, this one is prime.
Jeez.
That one is prime.
They're a bunch of hooligans.
All right, so we're going to go ahead and look at another one. And we're going to see. Okay.
I got this.
Negative 54w to the 4th minus 250wz cubed. Negative 54w to the 4th minus 250wz cubed. So now, very first thing we do, we look to see if we can take out something in common. So what is in common with the negative 54 and the negative 250? 2. Okay, actually, let's make this a negative 2. So we're going to take out a negative 2. The reason why we're going to make it negative is because the first term is negative. Now, is there anything else in common here? A W.
W.
Good. So I'm going to take out a negative 2w. When I take a negative 2 from negative 54, I get 27w cubed. When you take a negative 2 from negative 250, you get
125.
125
Z squared cubed.
z cubed, because I've already taken the w away. So then now I need to think, okay, 27w cubed, 125z cubed, I think these might be cubes. Let's see. What is cubed to give me 27? 3
Q.
W.
w. What is cubed to give me 125z cubed? 5z. Okay, so now my next row, what I'm going to do with those is I'm going to square them. So what will I have? 9w squared, 25z squared. So now I'm going to start with a negative 2w outside, a little set of parentheses, and a bigger set of parentheses.
Oh, I got this.
Okay, what goes in the little set of parentheses?
3W
3W
plus 5Z.
plus 5Z. Remember, my plus sign here should match right there.
I got this.
What will come next? 9W squared
Minus
minus
3W times 5Z
3W times 5Z.
Times 5Z
plus
plus 25Z squared.
Good, plus 25Z squared. So the last step will be to go ahead and do this multiplication right here, and then we're done. So negative 2W times 3W plus 5Z times 9W squared minus 15WZ plus 25Z squared.
So you don't multiply those at all?
Nope. Okay.
This is easy
So-
peasy.
That is how you use the factoring pattern, the sum or difference of two cubes. Okay, so real quick, what we're gonna do is I'm gonna look at a table in your book, and this is something I wanna introduce today. You don't need to write it down. I wanna introduce this today, and we're gonna talk about this eventually. I do have this in a flowchart form that I'm gonna give to you eventually as well. Okay, but real quick, first thing you are always gonna do, you always try to factor out a GCF. That's the very first thing. Okay, that's pretty much what we do. If you have two terms, you look to see if you've got the difference of two squares, which is what we've looked at. The sum of two cubes and difference of two cubes, which is what we've looked at today. Okay? Perfect square trinomials are what you look at for three terms. We don't really look at those so much as we look at the general trinomials. Okay? And then last but not least is grouping. So whenever you have four or more terms, you're going to look to group. And with that in mind, that's actually a great segue into this problem right here. This says to factor each polynomial if the polynomial cannot be factored right prime. So we need to count. How many terms do I have here?
1, 2, 3, 4,
6.
6, so I'm going to look to try and group.
You have 6.
Okay? And so when I look to try and group, I'm looking for things in common. So can you tell me what you notice about all of the terms?
First three have X's.
The first three have X's.
Second three have Y's.
Second three have Y's. Is there a number, first of all, that I can take out of all of them?
2. No.
Nope, there's not.
So I can't take anything out, so my next option then is to group them. You've already said that the first three have an X, and the next three have a Y. So let's go ahead and try and group them that way. So when I group them that way, what is in common
4x.
with the first group of three? Yep, 4X. Now when I take a 4X out, what does that leave me with?
2a plus
2A plus B plus C. Good. What can I take out from the second set?
3y.
3Y. What does that leave me with?
2a plus b plus c.
Plus
b
B plus,
c.
oh, what do you notice?
That was on parentheses.
What do you notice?
They're the same.
What are the same?
The
The parentheses. And so when you remember back to when we did factoring with grouping,
that is part of your answer.
that is part of my answer. So first part of my answer is 2A plus B plus
And
C.
then you take the other 2.
What's the other part of my answer?
4x. Take the other 2 and you put them in
4X plus
parentheses.
3Y. Yep, and if you're wondering where did the 4X plus the 3Y come from, that's where they came from. Now, why did I put that in front? It's generally accepted to put the one containing less terms in front, the one containing more terms next. So that's why, but you can put it either way. So that is your answer. So now what you need to do is start working on your assignment. You're not going to be able to do it all. You're only going to be able to do part of it. And the part of it that you're going to be able to do is that, now you're probably going to be able to do the first 6 or 7 problems. Okay, you're probably going to be able to do the first 6 or 7 problems. So tomorrow, this is what I'm going to need from you. I'm going to need your assignment from yesterday, the one with all the graphs. And then what it would be nice to do is have you have 20 through 25 done. Okay, tomorrow we're going to continue with more of this factoring. So.
May.